Alright everybody, let's get started with the next lesson in the polynomial section, and that is how to find the zeros of the polynomials. Now, so far we have understood what is a zero of the polynomial and what does it mean by the zero of the polynomial geometrically, etc. Now the question comes, the algebraic question comes, that how to find such period of the polynomials. Now let's take an example of a linear polynomial. Let's say suppose 2x plus 3. This is an example of a linear polynomial. We'll call this as p of x. Now we want to find this x value which gives you 0, right? That means what we will do, we will take 2x plus 3 equal to 0, and then we will identify for which value of x this polynomial is equal to 0, and that will give you the 0 of the polynomial, correct? That's the way actually you find out the 0 of the any polynomial, in fact. Okay, fine. That means the step 1 is, let me write here, step 1 is equate p of x with 0. Let me write 0 like this. That is, write p of x equal to 0. Now what is the step 2? Step 2 is solve p of x equal to 0 and find x. And step 3 is simple. Just write simply x is the, actually there is no step 3 actually here. X is a root. In fact, x is a 0 of the polynomial p of x. Hopefully that makes sense. Okay, what I'm trying to say here is we do have steps to make, or steps to find out the zeros of the polynomial in this fashion. We understood this without any trouble because we see here whatever we want to do was simply finding the zero of the polynomial. In other words, find out the value of x which will make this polynomial value is equal to 0. So that's what the step says. 1 says, and step 2 says, as well as the step 3 says. So step 3 is simply finding out or writing it what is the answer. That's all we do. Okay, fine. So let's find out the 0 of this. That means what we have to do here is, let me bring this person somewhere here. Let me not do this. So that's the step 1. That means what we can do right now here is, now we can write 2x equal to, I can bring this to this side, so that is minus 3. Now I can say this is x equal to, you see now 2 is multiplied with x, so I should do a division in the right hand side. And that means now what we have got here is the x value is minus 3 by 2. And what does that says? That says if you substitute minus 3 by 2 in the place of x, you will get 0. That's what it says, right? Why don't we verify this? So let's verify this. What we want to do? We want to substitute minus 3 by 2 instead of x. You see that I'm actually working with this. 2 times minus 3 by 2 plus 3. And what is that is? 2 and 2 gets cancelled, and that is minus 3 plus 3. And I know minus 3 plus 0 is equal to 4. And that shows that what we have found as a 0 is the 0, right? And this says that minus 3 by 2 is a 0 of p of x. Hopefully you can identify and relate to that. Okay, fine. Now, not just that, you take any linear polynomial, I can actually find out this way. Meaning, you can first of all think of that as any linear polynomial will be of the form p of x equal to some a times x plus b. Remember here, a cannot be equal to z. A cannot be equal to 0. Why? If a is equal to 0, then what will happen? This particular term vanishes, and that means only this term will be available, and that term is a constant, and that time I will not call this polynomial as a linear polynomial, whereas I will call that as a constant polynomial. So whenever I call it as a linear polynomial, that means the coefficient of the x term should not be equal to 0. That's the idea. So because it is actually is not equal to 0, what we can do right now here is, from the steps whatever we have done, we know that we wanted to do ax plus b is equal to 0, and that will imply ax equal to minus b, and that will further imply, remember a is not equal to 0, so I can divide throughout on the both side, and that gives me minus b by a. And what does that says? That says any linear polynomial I can actually push it to this side, and then simply I will put some command over here, actually some box over here, and keep it. So because this is something that we have found it from our own knowledge. Now what I wanted was, I wanted to find the 0 of this linear polynomial in general. Now I know that in general this is the linear polynomial, and equating with 0 gives you x equal to minus b by a. And that means for a linear polynomial, x equal to minus b by a is the 0 of the polynomial. Hopefully that makes sense. Okay, I forgot to make it as white in color. Let me do it. So that's the result that we have actually derived. So you take any linear polynomial, x equal to minus b by a is a 0 of the polynomial. Now question comes, what about quadratic polynomial? Quadratic polynomial. So can you find such a way that we can find out the 0 of the polynomial using such formulas or using such methods? The answer is yes, you can use a formula and you can still find out the value of the polynomial. Now first of all, you know that any quadratic polynomial must be of the form, to take a x square plus bx plus c. Remember here where a must not be equal to 0. I know that you know that very well, because if a is equal to 0, what will happen? This particular term vanishes, and that means only this term will be appearing, and that says this is a linear polynomial and not a quadratic polynomial. So we need a is not equal to 0. Okay, fine. Now because of this, what we can do is, you can go ahead and try to equate this. I can actually do this rough work here. In fact, that's the real work. You can say ax square plus bx plus c equal to 0, and then try to derive it what is my x value. Okay, fine. I'm not doing it here. What I will do is, I will right away write the answer here. So what is actually here is, if you substitute x equal to minus b plus or minus square root of b square minus 4ac divided by 2a, and that will be giving you the zeros. So these are the zeros of Px. Okay, good. Now there are some caveats over here. There are some advantages and the disadvantages over here. Now if your a, b, c, all of them are actually bigger numbers, you already would have realized that this computation is going to be too big. And another thing which is right now actually some coming around is the word called plus or minus. And what does that mean? That actually means there are two zeros are there for this quadratic polynomial, if at all if it exists, and that will be considered like this. It simply says the one 0 will be minus b plus square root of b square minus 4ac divided by 2a. The other one would be minus b minus square root of b square minus 4ac divided by 2a. Okay, fine. So here you also have to think about one more thing, that what if the value in the square root becomes negative? So if this b square minus 4ac becomes negative, which is less than 0, what will happen to the square root? We don't know, right? Because we haven't learned anything about square root of a negative number. So far, whatever we have learned is the square root of a positive number only. If you haven't realized so far, please actually keep a close look at it, that there are numbers which will give you b square minus 4ac is negative number inside the square root, which we don't know how to deal with it. Now I'm going to say only one more thing, that if suppose b square minus 4ac is actually less than 0, since we don't know how to compute it, we will go and say that no zeros, otherwise we'll find the zeros. That's the idea. Alright? Okay. So that brings this particular lesson to a close. Now what we will do is, in the next lecture, we will see some other ways of finding the roots of this polynomial as well, meaning the zeros of this polynomial as well, and we will get into that in the next lecture. And I will see you in the next lecture. Thank you guys for watching, and I will see you in the next lecture.